So hazards, we've captured quite a lot of different things in hazards. So we'll go with the void as the example. We've got a void, we've got a vehicle approaching a void here. If they get too close to that void, we get our A2. And if they continue to drive forward, they get our A3. But our voids are not our only hazard. Have quite lots of different hazards. Voids and unsupported ground are by far the most common. And they're usually managed quite well by the operation with a rather large earthen barricade to make sure that the machine doesn't drive off. But they do occur, and some operations may want to address this in their particular risk matrix. So it needs to be considered as a possible problem and look for solutions. We also have other variations of hazards. So we talked about voids and unsupported ground, but we've got things like sumps. So lots of operations won't barricade their sumps because they're concerned about some of the smaller vehicles driving into the sumps and getting immersed. And we've also got critical infrastructure such as an electrical substation. The last thing we want is a loader driving full barrel into a transformer or electrical substation. It'd be quite a catastrophic collision. And then we've got the more temporary installations such as a diamond drill. A diamond drill might be set up in a crosscut, and they're not there permanently. They're there for maybe 2-3 weeks depending on the campaign. They'll set a barricade up. So they're not a normal thing that the loader operator would see every single day if they were working the same area. It might be something new, something abnormal. So those are the sort of things that some operations may be interested in trying to sense and therefore notify the operator that, hey, you've got a hazard here you need to be aware of. For the stoping operations though, what must be considered is that there are lots and lots of voids, particularly in stoping operations, not necessarily in block caves or pillar operations. In stoping, there are loads and loads of voids scattered throughout the mine. So whatever technology we do develop for this particular problem, if a site is keen to solve it, the technology needs to be numerous in itself, right? It needs to account for that fact. So the image I've got there, that's a drive. Each of those cross cuts may be 20 or 30 meters separating from each other there as we go up the page. And that drive heading up the page might be another kilometre, maybe even 2 kilometres beyond what I've shown there in the drawing. So they are extensive, and that's just one level. There might be 20 or 30 levels in that operation. So there are a lot. They do exist. And as I said, most operations deal with it with an earthen bund, but some operations may be looking at technology to try and solve this one. So it's worth discussing and understanding if solutions are available. However, there is a variation to this, which is the false alarm, and that's where we deliberately want to approach that hazard. So in the case of the void, we deliberately do approach voids to tip into. So where we've emptied a stope, we will tip waste material into that stope to fill it so that we can take the next series of stopes around it. So it's important for ground stability that you do fill it. So I mentioned previously that we do have lots of voids, and that's not because the operation is lazy. It's because they're constantly emptying new stopes, filling them up and so that they can take more stopes. So it's like a sequence, a big cycle that's going on. So you do have activities where you deliberately want to approach that void or even dangerous ground, such as unsupported ground, to perform a particular activity associated with that hazard. So in the case that on the animation we've got here, that stope or that void will have a stop log there, and the loader will drive up onto that stop log and they will tip their load, which is the picture in the middle there. That's a typical stop log. So in this case, we don't want the alarm to occur because there'll be multiple tips per hour, per day on this particular example. So we don't want to be generating nuisance alarms in that particular case. There's other examples of what that could be. We've shown a stop log. Sometimes it's a grizzly, so you can actually drive on top of the void. It could be the unsupported ground, so you could have a jumbo approaching unsupported ground in order to set up and do some ground support work. It could even be a loader mucking out a sump. So a lot of operations will only allow a loader to enter a sump, and that's so they can muck out all the fines, all the mud that's built up, or the shotcrete fibres that are washed in, depending on the operation. So sometimes we actually need to deliberately do that. Again, though, like the previous one, if the operation does want to address it, they can be numerous, and they can also have a short time life. So an operation tries not to leave their voids open for very long, because it may hold the sequence up on another stope that they want to take down the track. So they try and fill it as quickly as they can. And as a result, the stop log may only be sitting there for a matter of days, maybe weeks, it's rarely years for a temporary fill activity. So the technology needs to account for that. It needs to be easily deployed, easily retrieved, easily redeployed as that stop log is used on that particular job and then relocated to another job to get that stope done. So that's something that needs to be considered as part of the design process. And then the last one is an example of a failure mode where infrastructure or mobile equipment could actually affect the sensoring capabilities on the mobile equipment. So this is, some failure modes that have been seen in the industry, and we'd really like, the industry as a group to work through and solve this problem. So in this case, we've got a HV driving past a transformer or a high current cable, and the sensors potentially have been compromised by that infrastructure. They've been adjusted, they might have been disrupted, whatever it may be, and you have the potential there to not see another hazard, i.e. the pedestrian in this particular example. So there's lots of different examples of that. I've put a lot of images in here around electrical. We're not saying electrical is the sole cause here. It can be iron. So you could have a lot of steel infrastructure underground. That picture there's a truck loading bay where they load a truck from an ore pass. So there's lots of steel infrastructure there. Are sensors susceptible to that steel? Not too sure, but we want it to be, questioned and considered as part of the design process. We've got the electrical one, so lots of high current, potentially generating magnetic fields there, depending on how the site has set up their electrical. Typically, they try and keep the magnetic fields to a tight frame because it has influence on other things. And then we've got the new one, which we're really interested to see how it progresses. There's not a lot of data on it, and that's our battery electric or hybrid vehicles. So how is technology going to work and perform on our battery electric vehicles in particular? A lot of people, we're keeping a close eye on this one because obviously with battery electric, you potentially lose one of your sensors because you've now lost your hearing. It's quite quiet compared to a big diesel engine roaring up the drive that you can hear from quite a long way away. You've got a much quieter vehicle. So you've got the potential of the vehicle sneaking up onto you. So it pushes more into the importance of how technology can play a part. So this is something we're really keen on understanding. So again, potential failure mode, want the industry to consider it, look at solutions that can help the industry shift forward on it.